Hey, Ann Pierce, this is Dr. Jones checking in. Good to virtually see you again. This is ANP1 Lecture Test 1, Video 9, and we're starting at the top of page 13, which looks like this. So we're going for this. All right, let's dig in. So, changing the structure of matter or moving an object is work. So moving your pencil around is work. If you take a piece of paper and crumple it, that's work. There you go. And energy is the capacity to do work. Energy is the capacity to do work. And there are two kinds of energy. There's kinetic energy and potential energy. Kinetic energy is the energy of motion. So if I drop my pencil, that's kinetic energy, the energy of it moving. Or if I roll it on the floor, that's kinetic energy. Potential energy is stored energy. So if I'm holding this up away from gravity, the gravity that's pulling on it, then that is potential. I am maintaining the potential energy. When I cease to maintain the potential energy, that energy gets transferred into kinetic energy when I drop it. So cell phone example, potential energy is a charged battery. And then kinetic energy is when you get a text or call or a tweet or a FaceTime or whatever they're called. Snap, but not Snapchat, like they changed it. I don't know. And your phone lights up or beeps or vibrates or it like strobe flashes and gives people epileptic seizures. I hate those strobes. And so that's the kinetic energy, the energy of motion, the doing things. Okay. Can energy be destroyed? Nope. It can only be converted. And generally, it's not 100% conversion. Usually quite a bit of the energy is lost as heat or light. And what is heat? Heat is an increase in the random molecular motion. So there's this thing called Brownian movement where all molecules tend to be moving all the time. The molecules in a solid are also moving, but they're just vibrating and at a rate that we can't see. So all molecules are moving. And you can see this, we talked about the motes of dust in a sun ray. And you can see them kind of floating around. So that's what I think of when I think of random molecular motion, the molecules floating around. And you can see that heat is an increase in the random molecular motion if you watch a pot boil. I know a watched pot never boils, but if you watch long enough, it actually will. And it just really speaks to impatience. That's all. It doesn't actually stop it from boiling. Okay, so when you're watching it, there is Brownian movement in the water where it is moving inside. You just aren't going to see it much. You will see it if you put like a drop of like food dye in there and watch it kind of diffuse around. And we will talk about diffusion for this test 1. But as the water heats up, whether you have dye in it or not, as it gets a little warmer, you start to see kind of currents moving around in the water. And then as it starts, like the little bubbles, the little bitty bubbles off the bottom that kind of don't make the way all the way to the top yet. And then you get like the little boil and then like the rolling boil, right? So the heat is that increase in the random molecular motion that you see when you watch a pot boil. Okay. Next. This is decomposition. Oh, let me get my Legos too. Uh-oh. All right. Get my bag here. And the Legos. Because what's more fun than explaining college level concepts with your children's toys? Now they're 11 and 14. They don't Lego much anymore. Now when they build things in Minecraft, like big kids. So, or Fortnite. Okay, so decomposition is when you have an AB. So we got AB here. And then decomposition reaction, here's the chemical reaction. Ta-da, A plus B. This is a decomposition reaction. So it breaks a molecule down, and it's written like this. The arrow means that a chemical reaction has happened. Okay, next let's talk about synthesis. So skip down to synthesis. Is the opposite of decomposition. So you start with A plus B, and then chemical reaction happens, and then boom, AB. And that's how that's written. Okay. Now, reversible reaction, this is reversible. That's not how you draw the arrows. It's just they didn't have chemistry arrows in wingdings. Boo. So this is how you write a freely reversible reaction. This is the arrow that you're looking for. These are the arrows that you're looking for. Gotta get a Star Wars reference in there somewhere. It's just creatively necessary. There will be more sci-fi references. You've been warned. Okay, so did we talk about? Okay, so on here I have hydrolysis is next. Okay, so hydrolysis is a type of decomposition. Hydrolysis, we're down here. We start with AB and a water. So let me get a water here. We've got 2 H's and an O. So here's our Mickey Mouse. What? They're Legos. H2O. So this is my water molecule. And this is my AB. So I've got AB plus water. And in hydrolysis, hydro means water and lysis means a loosening of. And this is a very useful root in science. We will use it a lot in anatomy 1 and 2. And it's used for everything between a loosening of, a digestion, and an explosion, which is my personal favorite because it's more fun. Okay, so in hydrolysis, we're going to break down the water. So hydrolysis. So we're going to snap an ear off of Mickey Mouse. Okay, that was wrong. Okay, and snap apart the A and the B because this is decomposition. And we're going to make an AH and a BOH. Let me get these in screen here. Dun da da da. Dun da da. Oh, that's stuck in my head. So that's hydrolysis. Moving on. And the opposite of hydrolysis is dehydration synthesis. Well, you start with an AH and a BOH and dehydration. So we're going to dehydrate. We're going to take the water out. We're going to take the Mickey Mouse ear off the A and the OH off the B, and we're going to create a water. So it's a synthesis because we're going from A plus B to AB, just like our synthesis reaction, but we've also made a Mickey Mouse water. Okay, so hydrolysis and dehydration synthesis are the opposites. Legos. It's all about Legos. All right, so let's go through the note set and make sure we covered everything on this page. Hydrolysis is a decomposition that breaks down the AB and also breaks down a water. Catabolism, oh, we didn't say that. Catabolism are all of the decomposition reactions in the body. See, I knew we missed something. All the decomposition reactions in the body. Synthesis builds a larger molecule. You're synthesizing. Anytime we say synthesize this semester or next semester, we're going to mean make. So synthesis, we have made something. We made an AB molecule. And dehydration synthesis is synthesis because we're going from A plus B to AB, but we're also making a water, which is weird because it's dehydration, but we're taking the water out of these first two. So we're going with it. And then anabolism was the other bit we did not cover, and that is all the synthesis reactions in the body. And then diagram a simple decomposition reaction, you've done that. A synthetic reaction, you've done that. And a freely reversible reaction, use the correct arrows, please. Not the wingdings, that's not, no. Wingdings, what you gonna do? Okay, the amount of energy needed to start a reaction is the activation energy. And the enzymes lower the activation energy in order to make chemical reactions possible in the body. Enzymes accelerate chemical reactions and are not consumed, so they can be reused. Are all enzymes proteins? Yes. Enzymes are proteins. Are enzymes consumed / used up by the chemical reactions they activate, or can they be used again? They can be reused. So in this chemical reaction, decomposition reaction where we go from AB to A plus B, the activation energy required to pull these two Legos is probably not going to happen in nature. Probably not. By itself. These two Legos are not going to just loosen up and fall apart. They're really well made. It's amazing. In order to get these apart, we have to use an enzyme. So my fingers here are the enzymes that pull these apart. Now, were my fingers destroyed? No. Okay. Now, if you step on them, is your foot destroyed? Then you can make that argument. They leave dents. But my fingers were not destroyed in the process, and they can be used to pull other Legos apart. It can be used again. Okay, so it will be a different enzyme that will put them back together. Because each enzyme is very specific. Okay, page 14, and I forgot the timer again, didn't I? Okay. Diagram the dissociation of water. My head is in the way. Okay, and again, the arrows go like this. Okay, sort of like that. The dissociation of water, H plus OH minus. Acids release H plus, which lowers the pH. Bases release the OH minus, which raises pH. So what does any of that mean? First of all, let's finish this note set bit on page 14. Is this a reversible reaction? Yes, because we have our little reversible reaction arrows going on. Is this a balanced reaction? Well, this is H2, so we have two H's on this side, two H's on this side, one O. So yes, this is a balanced reaction. Write the chemical notation for a hydrogen ion, H+, and the chemical notation for a hydroxide. Hear that oxy? So the oxygen, we usually have the oxy, OXI, or OXY. So this one's an OXI for oxygen. Which of these two is a cation? That's right, the hydrogen ion. And which one is the anion? The hydroxide. Neutral. Neutral is a pH of 7. And technically this is a logarithmic scale, but we use the simpler numbers because, again, not a chemistry class. Example of a neutral, pure water. A low pH, which is a number smaller than 7, 6, 5, 4, 3, 2, 1, 0. Okay. These are things that are acidic. An example, well, we've got stomach acid, we've got tomatoes, hydrochloric acid. High pH, a bigger number than 7, so 8, 9, 10, 11, 12, 13, or 14. And these are things that are basic, as in alkaline, not like basic. That's as the opposite of extra. This is basic, the opposite of acidic, different basic. Examples, we've got bleach, ammonia, oven cleaner. Okay, important note here, don't mix an alkaline with an acid. So don't mix bleach and vinegar because it makes toxic fumes and it will knock you out. Don't even mix bleach and ammonia. That still makes terrible fumes that are, no. Don't mix basically bleach with anything except like water. You can dilute the bleach, but don't mix the bleach. If that makes sense. Toxic fumes, bad for you, kill you, knock you out. Safety first. Okay, so neutral, 7. Oh, and pH is lowercase p, capital H. Neutral is 7. A number smaller than 7 is acidic. A number bigger than 7 is basic or alkaline. Okay, next. We're skipping sections 2.5, 2.6, 2.8, 2.9. 2.6 we are covering in chapter 3. So that is on test 1. So if you'd rather learn it in that part of the chapter 2, that's fine. Doesn't make a difference. Okay, so let's talk about sugars. We have monosaccharides. Okay, sugars, carbs are sugars and starches. Let's start with the note set. Monosaccharides are simple sugars, and give some examples. And here we are. We've got glucose, fructose, and galactose. The most important metabolic fuel in the body is going to be the glucose. And if you stick 2 monosaccharides together, mono means 1, di means 2. So disaccharides are 2 monosaccharides bound together. Example, sucrose, and that's our table sugar, the regular just sugar, white sugar, and that's glucose plus fructose. So it's these 2 together. Another example is lactose, and if you're lactose intolerant, you've certainly heard of this. And lactose is the glucose and the galactose. So what happens in lactose intolerance is that you don't have enough lactase. So you see how all of these end in OSE? These OSE tells you that it's a sugar. So the enzyme that breaks the lactose down into the constituent glucose and galactose is called lactase. Anytime you have ASE, it's an enzyme. OSE is a sugar. So that one letter in science can make all the difference in the world. All the difference. So lactase is the enzyme that breaks down lactose. And if you eat lactose and you don't have lactase, then that will cause, politely, gastrointestinal distress. Yes, let's call it that. A polite way to put it, because if you can't break the lactose down into the constituent glucose and galactose, it causes issues. Like keep the toilet free issues. Polysaccharides, poly means many. So polysaccharides are lots of monosaccharides bound together. Example, cellulose, which is plant polysaccharides, and glycogen, which is an animal polysaccharide. And glycogen is just a bunch of glucoses pop beaded together. I've got a picture here for you. So this is a glucose, this is in its ring structure, how it is normally found. And then these ring structures just kind of pop bead together in kind of a branched pop bead structure. And this is called glycogen. And we will come across the term glycogen in ANP1 and ANP2 several times, but fairly spread out. So whenever we find this, I will remind you that glycogen is a sugar storage molecule. It's found, we're not there yet, but it's stored in the liver and the skeletal muscles. So that's about what you need to know about that. Coffee. Okay, and Okay, glycogen is made of glucose molecules, functions as energy storage in the liver and muscles. You do need to know that. Okay. The building blocks, and monomer, that term monomer means building block, and that will be used in test question jargon. So building blocks is the English explanation, monomer is the test question jargon. So you need both the jargon and the English. What does that mean? The building blocks of carbohydrates are monosaccharides. And I do want to take this time to say that we're talking about human anatomy and physiology. So we are about to do in chapter 3 the cell parts and the cell membranes. And in lab 1, we're also doing the cell parts, including the cell membrane. But in animals, there is never in any way, shape, or form a cell wall ever. Plants have cell walls. There are some of the single-celled organisms, but not all of them, have cell walls. But animals don't have cell walls. Mushrooms don't have cell walls. No cell walls. If you put cell wall on the lab, I will strongly consider taking extra points off. Strongly consider. Okay. So we did page 14. Did we do 2 pages? We did 2 pages. So we will call it good. 13 and 14. So we will start the next video on the top of 15. How many pages do we have left in this chapter? 15, 16, 17, 18. So 2 more videos, 2 pages each. Sounds good to me. So thank you as always for tuning in. This has been A&P 1 lecture test 1 video. Checks notes 9. Just looked at it. The education must go on. Dr. J out.